Having studied the question of finding global extrema on bounded domains, we now open it up to a challenge where the domain is not bounded at all. And so the domain could be, for example, all of R2, all x and y values that we can imagine. And as soon as we do that, we actually get into a whole pile of trouble. It turns out that complicates life far more than you might expect. Determining whether there is a global minimum or global maximum at all is actually very difficult, and we almost have to do it on a case-by-case basis, making arguments. In the previous examples with the bounded domain, we had a nice rule. There always was a global max, but here we get into trouble. So what we're going to do is limit ourselves to relatively simple problems and focus on simple arguments for that. All right. Now let's ask a question here about our favorite paraboloid shape, the f of xy equals x squared plus y squared, which again is this parabolic bowl shape. So x, y, and z, that's the 3D version. And if we looked in contours to compare it to the previous examples, we would have a 0 at the middle, then 1, 2, 3, and 4. All right, and going out further. So, can this function have a global maximum? Can this function have a global minimum? From this picture, I hope it's clear that we're talking z values is what we're comparing. There will be a global minimum at the center here, at the origin. Everywhere else the function goes up and up because this function is always greater than or equal to 0. We can see that in the contour diagram as a combination of a local min, and then understanding the whole function leads us to that being a global min. We know the function values always go higher as we move out and out and out. Okay, what about the global max? Global max. Well, this is where you get into maybe some what seems like abstruse logic, but here's how I think about this. Does f have some upper limit? So we're looking for a maximum. Is there some limit I can put on f? In other words, is f always less than 100? Or less than 1,000 or less than 1,000,000? And if you look at your function and recognize that I can pick any x and y at all to put in here, then here's how I work the arguments. Someone says that there is a global maximum. Say 100 is the highest f can ever get. Then I try to find a counterexample and say, well, if I make x big enough, or y big enough, then I can get the function value to go higher than 100. Because if I'm going to take some number like 100 squared, it'll be 10,000, it'll be bigger. And so if someone claims there's an upper limit, or that there is a global max, then we have to make these kinds of arguments that, no, that can't happen, because x squared is going to increase towards infinity with no upper bound. There's no cap on the x squared term, because we're on an unbounded domain. I can go out as far as I want, and the further I go out, the bigger x squared gets. So there's no upper limit on the function. And if there's no upper limit on the function, that means there can't be a global max. A global max is a single point where the function hits its upper limit. If there is no upper limit, then there can't be a global max. So I'll let you think about that for a bit. We'll consider it in this new example, and you'll see some problems like this in the assignment, the practice problems. How about the function x squared minus y squared? Does it have a global maximum? Does it have a global minimum? Drawing the contours and understanding the shape of this function is a little more complicated, and in fact we don't really want to do that if we can avoid it. It's nice to have the pictures, but we'd rather work directly with the formula if we can. So the question comes back though, does f go out towards infinity, or does it have an upper limit? If we can answer that question, if the function does have an upper limit somewhere, then it has a global maximum. But if the function goes off to infinity, and here's the key thing, in some, or in fact in any xy direction, then we've got the two scenarios. If this is the case, then there's no global max. If this is the case, if there is actually an upper limit, then there is a global max. So we're looking for these two scenarios, and we're going to consider that by looking at the formula. So we ask ourselves, is there any way I can imagine this function getting bigger and bigger and bigger forever? And I think we can pretty easily here by letting x increase and keep y equal to 0. If we make x bigger and bigger and bigger, this is going to go off to infinity, and I'm going to add 0 to it. So I can make this function as big as I want, so I can make this function go towards infinity in some direction. It means there's no upper limit, so there's no global max. We're contradicting the idea that there might be a single fixed point where it hits its maximum. And in an exactly analogous way, we can make the argument about global min. Does f approach negative infinity in some or any direction? Can I find some path where the function approaches negative infinity? Well, we certainly can, because there's a negative out front of this negative y squared. So this could go to negative infinity while I keep x at 0. So let's let y increase and keep x at 0. That'll lead to minus y squared heading towards minus infinity, So the function gets smaller and smaller, bigger and bigger negative values, and in that case, there's no single stopping point for the function. There's no single point where the function reaches its max or absolute minimum. So there cannot be a global minimum in this case either. So this function here would have no global max and no global min if we allow all possible x and y values. Notice we're throwing in infinities here and letting y be bigger and bigger and bigger. The contrast from the earlier examples was when we had a bounded domain. If we said, there is a limit, y can only go up to 5. Oh, well then I can push y to 5 and get as big a negative value as there is, but I would stop at some point. So the key thing for analyzing these scenarios, or recognizing the difference between scenarios, is if no bound is given, if they just say, here's a function, does it have a global max and or min, you have to assume that you can pick any x and y values you like all the way out towards infinity, and that can result very easily in functions having no global max and no global min, or, as in the previous example, maybe one of the two might have a global min but no global max. You have to reason through each case separately, and the logic to use there is to ask yourself whether you can make this function get larger and larger without a bound, then there's no global max, or if you recognize that there would be a limit on the upper bound, then that would indicate that there is a global max.